Hello and welcome to Math200 Statistics here at Cañada College. My name is Lapuz. In this video, we will go through a problem from section 11.4. This is problem number 1. They're asking, is there a difference between community college statistics students and university stat students in what technology they use in their homework? Of a random selected community college students, 69 used the computer, 88 used the calculator with built-in stats functions, 22 used a table from the book. And then the university students, 46 used a computer, 77 used a calculator, and 34 used a table. Conduct an appropriate test and use a 0.05 significance level. So this looks like it's a comparison between community college students, so we'll call it CC students, and university students. And it's a comparison of different categories. So the categories look like there's people who use the computer, a calculator, and tables from the textbook. So I think this is a setup for a test where there are two different populations that we're considering, and we want to know if the distribution between these two populations are generally the same. And that is a test for homogeneity. So let's select that for the first slot. And now next they ask, what is the null and alternative hypothesis? With something like this, we're talking about the distribution being the same for the null hypothesis. So in the null hypothesis, the distribution, here it says not the same, so this is not it. We're not looking at dependence or independence, so it's neither of those. And here we're looking at the technology is going to be the same for both populations. So this would be the null hypothesis. The alternative would be the difference, that they're different, again, not independence or dependence. And so here it says that they're the same, but for the null hypothesis, we're looking at this being different or not the same. So this is going to be our choice for our null hypothesis. The rest will ask us to find their test statistic, p-value, etc. So we'll need to actually do the computation in our technology. So for this, we will need this information. Now, they didn't give us a table like this, but we need to create a table like this. So let's come back and create this table and look at the number of people in a community college setting that used a computer. So there's 69 of them. That used a calculator, 88, and that used a textbook, 22. And then for the university students, 46 used a computer, 77 used a calculator, and 34 used a table. So let's take this table and recreate it in our Google Sheets file. Let's see if we could do this. Just copy this table and let's try to put it here. Now obviously we're not going to be able to use this table in the Google Sheets. It would have been nice, but we have to actually create it ourselves. So let's do that in this little space. So this is the community college and university, and the categories are computer, people who use a computer, people who use a calculator that had statistical commands, and the tables from the textbook. So we had a 69 for the first one, 88, 22, and then a 46, 77, and 34. Okay, so that's our table. Now we have our table here, and again we're going to need the row and column totals just like we did for the test for independence. So let's enter our column totals first. So equals, since there were just two things, we can just literally click on this and say plus this, or we can use the sum function. And I think if we use the sum function, sum, S-U-M, and then click and drag those two, and then you press enter, and you're going to get the same result. So let's extend that for the other two columns, and then we want to find rows. So this is equal to, and then we'll use the sum function for this, SUM, open parentheses, and then click and drag, and then press enter. Here they ask, do you want autofill? And I think this is a good time to just say yes, because we could autofill the second row, and we also can autofill the sum of the column totals, which will give us the sum of everybody that was in this survey. Okay. All right, now we're going to need this portion of the table, just the data portion of the table, repeated for our expected value, except we're not going to use these same numbers for expected value. We have to actually compute our expected value. And then we're also going to need this piece of table for our next one. So I can just, I clicked this corner that would include this whole table, and I'll say Control-C for copy, and then paste it onto my O minus E squared divided by E table. Okay. All right. Let's go first to the expected table. Here, just like we computed for the test for independence, this is going to be equal to the row total times the column total divided by the grand total of that particular cell. And so we get 61.26. So let's do the computation here. Equals, this is the first row total times the second column total divided by the grand total. And then the last one is going to be equal to the first row total times the third column total divided by the grand total. All right, we'll do the same. We got one more row. That's for the second row times the first column divided by the grand total, and then equals the second row times the second column divided by the grand total, and then one more, the second row times the third column divided by the grand total. Okay, now we have our expected values, and let's create another table, a third table that would do the computation that we're going to need for our test statistic. Okay, and we're going to want the sum of the test statistic here, so we can get that prepared now, saying this is going to be equal to the sum of all these values in here. And our sum, remember, can be done in a one-dimensional list or a two-dimensional table like this. And so right now there's nothing in there, but let's do the computation. So in our first slot, we'll say equals to the observed values. So that's the community college students that use computers. Oops, I forgot my parentheses again. So parentheses, and then the observed values minus the expected values, divide, or close parentheses, quantity squared, and then divide by the expected values. Okay, now it has an autofill, or you can choose the autofill or not, and then we'll just click and drag ourselves. But right now this is our first number, and that's beginning to add up to everything in this table. So I'm going to take this and click and drag down, and I'm going to take that and click and drag across until I get my my 2x3 table figured out. And so with that, I have my test statistic. Now I want to figure out my degrees of freedom. The degrees of freedom is going to be the number of rows minus 1 times the number of columns minus 1. So there's only 2 rows, and so for the test of homogeneity, since we're only comparing 2 populations, the rows, you're always going to have 2 rows, and so that's just going to be 1 times, and then whatever many number of categories you have, minus 1. So there's 3 categories minus 1. That's going to give us a degrees of freedom of 2. All right, so now we got our degrees of freedom, and once we got our degrees of freedom, and this is a chi-square distribution, right tail, where we put in the test statistic and the degrees of freedom, and then we get our p-value. Okay, so now that we have all that information, or really these are the only pieces of information we need, or really just the test statistic and the p-value, let's put this off to the side and come back to our paper, and let's put in our test statistic. So our test statistic is, again, a chi-square test statistic. They don't ask you to identify your variable for test statistic, but we should put chi-square there. And then we got a 6.492. That's good to 3 decimal places. And our p-value that we got here was 0.0389. And so that's our p-value. Now, compared to our significance level of 0.05, our p-value is less. So PV is less than alpha. This is less than. And so we reject the null hypothesis with a small p-value. So the null hypothesis was saying that they're the same, but we are rejecting that, so we can say that they're actually, we can support the claim that they're different. So which one is it? Sufficient evidence to show technology use. Okay, so let's cross out the dependent and independent, because we know it's not a test for dependence or independence. Sufficient evidence to conclude that distribution is the same, or it's not the same. So it's not the same. This looks like it's a good candidate for that, but let's read the rest. There is insufficient evidence. So I think because we rejected the null hypothesis, and then we actually will support the claim. So we're looking for some significance, statistical significance of sufficient evidence of support. So I don't think it's going to be this one. Sufficient evidence to conclude that technology is the same. So this is saying it's the same, and this is not what we wanted because we rejected the statement that says the same. So we'll stick with the second one as our choice. Okay, and then that's it. So this is our test for homogeneity. I hope that helps. Good luck.